Hello guys, welcome back to my channel Algorithm Mind. My name is Hassan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach theoretical concept as well as practical programming skills in data science, data analysis. So if you want to learn programming from scratch, I request you to subscribe to my channel and hit the notification bell icon button. So for today's tutorial, I'm going to teach you about how we can actually implement mixed integer linear programming in MATLAB. This is an optimization technique that is used to solve problem where some of the decision variables are required to be integers while others can be continuous values. It is useful in various fields such as research operations, logistics, finance for solving complex problems. So in order to get a brief introduction about mixed integer linear programming is such that, for example, we have an objective function and we want to actually optimize it. By optimizing the objective function, I mean that we either need to increase its value to the maximum or decrease its value to the minimum based on and subjected to the constraint that the function has. Okay, so it's all form of mathematical game where you actually have to deal with first of all the equations to form an objective function. Then you have to find the constraints that are also in the form of equations. Okay, so I'm going to teach you step by step in this MATLAB tutorial, so how you can actually solve an optimization problem in MATLAB. This is done for a very simple case, and similar scenario can be adopted if your problem is lengthy or complex, but the working flow in MATLAB to solve a MILP problem is the same as I'm going to teach you in this course. Okay, so in MILP, the objective function is a linear function, either minimized or maximized. Decision variables can be integers. Okay, so the decision variables must be integers that must satisfy all the constraints and also minimize the function as well. So integers are like 1, 2, 3, 4, 5, 6 and so on. And we can also set decision variables to be continuous. In that case, they can have some floating point values as well, like 5.5, 5.6 and so on. And these values or decision variables can also be binary, that we restrict them that to a value of 0 and 1. So it represents binary states. Okay, so the objective problem that we are going to solve in this code is here. Okay, so this is our objective problem. Okay, so we need to minimize an objective function that is 8x1 plus x2 plus 3x3. So this is an objective function that we need to minimize, and the variable in this case x1 is a continuous variable, so it means that x1 can take a value of 1, 1.2, 1.3, 5.5 and so on, while x2 will be an integer. Its value will be like 1, 2, 3, 7, 8, 9, but not 1.5, 6.5 as floating. And x3 will be only binary integer, that is its value will be either 0 and 1. So these are some of the conditions of our process variable, and this is our objective function. Now let's go move towards inequality constraints. So these are the constraints that our solution must satisfy and then find the minimum value of our objective function. So these are the constraints that must be satisfied in order to meet the objective function or minimize solution. Okay, so we have first inequality constraint. Why they are called inequality constraint? Because they have equal to and greater than value sign in it. Okay, so that's why they are called inequality constraint. So we have like x1 plus 2x2 minus x3 should be greater than or equal to minus 14, and then the second one is minus 4x1 minus x2 plus 3x3 should be less than or equal to minus 33, and the last one is 2x1 plus x2 plus x3 is less than equal to 20. So these are the inequality constraints. Now moving on to the quality constraints. Okay, the reason why they are called equality constraints, because they have an just equal to value instead of like in quality constraint where we have greater than or less than sign. So here's an equality constraint: x1 plus x3 is equal to 5. So you might be wondering that where is the x2? So here the x2 in this case has a coefficient of 0. So the equality constraint will become x1 plus 0 x2 plus x3 is equal to 5. That being said, we also have some bounds based on the conditions we have defined earlier. So we say that x1 and x2 must be greater than or equal to 0. So we are setting the bound that x1 x2 should not be a negative number, they must be greater than 0 number, and in our case we are setting x1 into continuous and x2 to be integer, and x3 can only take the value of 0 and 1 as a binary function. Okay, now you understand the objective function, you know the decision variable, you know the inequality constraint, you know the equality constraint and bounds. Let's move on and actually implement that problem in MATLAB and optimize the function to get the values of x, y, x1, x2 and x3. So this is a form how you define an objective function. So for example, you let's say you have three variables here, x1 plus x2 plus x3. So these are three variables here. So what you are going to do, we are going to define the coefficients of those variables in the objective function. So you will initialize a variable named objective fun is equal to, then you will define a matrix of one row and column equal to the number of variables that are present in your objective function. Here we have three variable in the objective function. So we have three elements that correspond to the coefficient of objective function. Now, after you have defined the objective function, let's move on and actually define our inequality constraints. So in order to define inequality constraint, you have to remember that they must be represented in this form. That is, ax should be less than equal to b. Okay. For this reason, we are going to change the coefficients of our first inequality constraint in order to make it represent this form. Okay, so that can be easily done by multiplying minus sign with both sides. Okay, so we will multiply minus sign on both sides, and by doing that, we will convert this form here into this form, ax less than equal to b. Okay, so for the rest of the two inequality constraint, we have like less than equal to minus 33. We have like 2x1 plus 2x2 plus x3 is less than equal to 20. So, okay. Now that being done, what is a and what is b? A is the coefficient of the variable that are currently attached to this inequality constraint. For example, we have 1, 2 and minus 1. Which when multiplied by minus 1 will be minus 1, minus 2 and plus 3. And then we have like coefficients say of this second inequality like minus 4, minus 1 and plus 3. And then last one is 2, 2 and 1. So these are the coefficients of inequality constraints here. Okay, minus 1, minus 2, 1. Then colon is denotes that we are going to represent another row. So this will be second row and this will be third row. So A is a matrix of 3 rows and 3 columns. In the same way, we will define B, which have like when we multiply by minus 9, it will become 14. And the second row will become minus 33 and the last row will have 20. So that's how you define inequality constraints. Okay. Now, after defining inequality constraint, let's move on and actually define our equality constraints. This is the equality constraint example. I have made a slight changes to this solution because with the 5 value, we were not getting a feasible solution. So that's why I set it to 6.5. That could happen like you set up a constraint in such a way that there is no such optimum value or there is no such feasible solution for that problem. That being said, so we have our equality constraint x1 plus x3 is equal to 6.5. So it is quite simple one. So we will define it, the coefficients of equality constraint. X1 is 1. Then we have 0 for x2 because there is no x2. So that means it has a 0 coefficient. Then we have 1 for x3. That being done, now we will define BEQ, which is 6.5, which is the equal to sign and that value. Now let's move on and just a brief overview. You define the objective function, you define the inequality constraint, you define the equality constraint. Now you need to define in this function intlinprog, you need to tell this function what variables will be treated as integers and what variables will be treated as continuous. So this variable here intcount will help this function to understand what variables are integers. Okay, so here we are giving the index of second variable and third variable to be integer. Okay, so let me repeat that. So here in count we are giving the index of second variable and third variable to tell this function intlinprog that second variable, third variable are actually integer variables. Once we done that, now we will set the upper boundaries of x. That is, we will evaluate the solution that should have the minimum value of x and the variable that should have the maximum values of variables. Okay, so in that case, if you recall that in the problem we say that x1 and x2 must be greater than 0 and x3 must be equal to 0 or 1. Okay, so that's we need to define in this ul and ub. Ul stand for upper lower boundary, and ub stand for again upper boundary. Okay, so we have for lower boundary, we'll define the range of each variable here with the help of semicolon. So basically it's a 1 column and 3 rows matrix, where we say that the minimum value of x should be equal to 0, 0, 0. Okay, and then for the upper bound we say its value is infinity for x1, its value is infinity for x2, and its value is 1 for x3, because we say that x3 must be either be 0 or 1. Now you have actually defined all the parameters that actually needed by this function intlinprog. So let's move on and actually define our function here. So this is the function intlinprog, and we are passing number of input arguments to this function. Okay, so before we jump into the function, so after like doing the calculation, the lintprog will give us the values of variable like x1, x2 and x3 that will be stored in this variable x, and it will also give us the optimized, or in our case minimum value of objective function that will be stored in this variable declare. Okay, now let's move on to the input arguments that have been taken by this function intlinprog. So first of all, we have an objective function which we defined the here 8, 1, 3 corresponding to 8x1 plus 2x2 plus 3x3. Then we have intcount, which defines what variable should be treated as integer. We have already defined that second and third will be treated as integer. Then we have equality, coefficients of equality constraint, inequality constraints. Okay, inequality constraint, and then we define its its constraints. Okay, there's 14 minus 30 and 23. Then we have the coefficients of equality constraint here, AEQ, and then we define the BEQ, and finally we will define UL and UB. So this is a way how you actually define the input arguments for this function in intlinprog. Now once you've done that, when you run this code, it will do the optimization and it will find the optimum objective value. In that case, the minimum objective value is 55. Okay, it says that it has found the solution, that's why it stopped. Okay, and once we run that, we will learn to see what are the values that we are getting out of it. Okay, so we will simply use this x to display the value of x. Now you can see that x1 was treated as a continuous variable, that's why we have like 5.5 value, and x2 was defined as integer value, that's why we have x is equal to 8, and we defined that x3 must be binary value, its value can either be 0 and 1, and that is exactly the solution we are getting based on the constraint we have defined to this problem. And finally, let's display the optimum objective function value, which is 55. So that's it for this tutorial. I hope you are able to understand the functionality of intlinprog and how you can actually solve a mixed integer linear programming in MATLAB. And this similar approach can be used to solve complex problem as well. So I hope this tutorial have been helpful. If you have any questions regarding today's tutorial, feel free to write down your comment. I will be happy to help you out. I will be publishing more tutorial videos on optimization and machine learning in MATLAB. So I request you to subscribe to my channel and hit the notification bell icon button. Thank you for joining me, and I will catch you soon in the next video.